Hi, in today's lesson, we're going to talk about function notation. So first thing, I want you to pause the video and read through this information. Great. Now let's practice. All right, so we're going to evaluate functions using that function notation, and you are allowed to use a calculator if you need one for this. So the first example, it says given f of x, not f times x, f of x is equal to 7x minus 1, find f of negative 2. So if I'm going to do f of negative 2, all I have to do is substitute a negative 2 everywhere I saw x. So we're at 7x means 7 times x. So I'm going to do 7 times negative 2 minus 1. So that'd be negative 14 minus 1, which is negative 15. So f of negative 2 is negative 15. Let's try another example. In example 2, it says given that g of x is equal to x squared minus 4, find g of negative 5. So I'm going to do g of negative 5. Now, x squared, so I'm going to do negative 5 squared. Remember that negative 5 should be in its own set of parentheses. So negative 5 in parentheses squared minus 4. Well, negative 5 squared means negative 5 times negative 5, which is 25. And then 25 minus 4, 21. So g of negative 5 is 21. Okay, example 3 says given that h of x is equal to 5x minus 1, find x if h of x equals 9. So this is different. This time they're telling us what h of x is. So in place of h of x, I'm going to put a 9. So you're finding x. In other words, solve the equation 9 equals 5x minus 1. So we already know how to do this. So we'll add 1 on both sides. 10 is equal to 5x. Then divide both sides by 5. 10 divided by 5 is 2. So if h of x is equal to 9, then x would be 2. Let's try another example. All right. Let me move this down. There we go. In example 4, it says given that f of x is equal to negative x plus 2, find x if f of x is 6. So they're telling you f of x is 6. This isn't find f of 4 or whatever. This isn't put a 6 in place of x. This is saying put a 6 in place of f of x. So if I do that, now I can solve the equation for x. So I'm going to say 6 is equal to negative x plus 2. What's x? So we already know how to solve this. Subtract 2 on both sides. So 4 is equal to negative x. Negative x, remember, is the same as negative 1x. So we're going to divide both sides by negative 1. So I get that x is equal to negative 4. Okay? So those are our 4 examples. Let's turn the page. And I want you to do the let's practice part. So you're going to do all of these. Okay? So that's problems A through H. So I want you to pause the video and complete those problems now. Okay, so hopefully you did well with these problems. So you're going to want to pause the video and check your answers, make the necessary corrections. I do want to point out for H, notice when I got that 16 is equal to x squared, x could be 4 or it could be negative 4. 4 squared is 16 and negative 4 squared, meaning negative 4 times negative 4 is also 16. All right, so let's look at this bottom part. This one has some graphs, or has a graph, I should say. It says not all functions are expressed as equations. Here's a graph of a function g. The equation is not given, but you can still use function notation to express the outputs for various inputs. So for example, if I want to find g of 0, I'm saying my input or x value is 0. So what's the corresponding y value? So if I find 0 on the x-axis, it would be right here. And so if I want to move up until I hit the graph, 3. So the corresponding y value here would be 3. Let's try another one. G of 4. So I find 4 on the x-axis, which is here, and I'm going to keep going until I hit the graph. I hit the graph, and that goes with 6 on the y-axis. So G of 4 would be 6. Let's try G of 6. So I find 6 on the x-axis, boom, hit the graph. And as soon as I hit the graph, I'm going to come over here. That would end up being a 1 on the y. So the y coordinate there would be a 1. Number 4, can you find x values for which g of x is equal to 3? So this time they're telling us the y value is a 3. So find 3 on the y-axis, which is here, and then move until you hit the graph. Well, I hit the graph right here. I also hit it right here, so that's at 0, 1, and 2. I hit it again, right about here, which is about, 4.7 maybe, 0, 1, 2, maybe 4.7, and I hit it again at 9. So I'm going to write 0, 1, 2, maybe about 4.7, and we said at 9. So there are several values. Now, number 5 and 6 both have a typo. It says if f of x, make that say g of x. So number 5 says if g of x is 6, what is x? So meaning if the y value is 6, what's the x value? So I'm going to go from 6 on the y-axis until I hit my graph. And when I do, I hit it here, which corresponds to an x value of 4. Okay, let's do it again. This time, if g of x is 0, what is x? So find 0 on the y-axis, which is right here. And I'm going to move over to the right. There we go. I'm going to move over to the right until I hit my graph. And I hit my graph right here, that bottom point, at 7. So that's going to be a 7. All right, problem 7, what's the domain of this function? So remember, when we talk about domain, we're talking about all the possible x values, which is from here to here. So we could say the domain goes from 0 to 12. If I write that in interval notation, it would look like this. I need a bracket around the 0 and the 12 because those are both definite values. If I write it using the inequality, it would be 0 less than or equal to x less than or equal to 12. Now let's talk about the range. So my range, the bottom, change a different color, goes all the way down here, and it goes all the way up to, looks like at that 6. So my range would go from 0 to 6, and I do need brackets around that because 0 and 6 are definite points. If I write it using the inequality statement, that says 0 less than or equal to y less than or equal to 6. All right, now try this problem on your own. All right, welcome back. Check your answers to this problem. If you have any questions at all, please make sure you contact me. Once you've submitted this assignment, then you'll be ready for your independent practice. Good luck.